Okay, so far I have shown you a few examples of integration where doing it in one direction is easier than the other direction, although both give you the same result. Now here's an example where trying to integrate in one direction becomes impossible, and you have to change the order of integration in order to make sense out of it. Okay? So suppose you have a double integral that looks like this. Now, we all know that integral of e to the x is what? E to the x, right? Now, does anyone know what's the integral of e to the x squared dx?
1 over 2x.
No. You can try everything that you know about integration, like u substitution, integration by parts. You can try anything that you know. You'll see that there's no way to get this answer. Okay. Now, if you take this and plug it into, say, something like Wolfram alpha, it will give you some strange functions that you've never seen before. Okay. So something like error function, blah blah blah. Yeah, very strange. Okay. So unfortunately, this does not have a known form of integral. Okay. So this question, if you try to solve it as it is, it won't be possible because you can't integrate e to the x squared. So in such a case, you might ask, how do we do this then? Well, because this is only a function of x, if you integrate by y first, that's doable, right? If you integrate by y, then we're doing partial integration, so you're thinking of x as a constant. Integrating a constant is easy, yeah. And somehow that's going to be helpful for the other integral as well. So the only way to solve it is if you change this order of integration. Now, how do you change the order? You might say, oh, okay, so change these, so should we change this one? Does that work? And the answer is no. You can't do it that way because these bounds are very elaborate. It has to be curve to curve and then point to point. If you simply switch them, then you end up with point and then curve out on the outside. It doesn't work. So the only way to change the order is first you have to interpret what this integral means, and then after drawing the domain, we have to change the order. Okay, so let's think about this. What does this 2y mean? 2y really means x equals to 2y, right? And 2 really means x equals to 2. Remember, dx being here means x equals to 2y and x equals to 2. Okay? And then you have to draw these two things. X equals to 2, what is that? What is that in xy plane?
Up and down.
It's a vertical line, right? So here's 1, here's 2. It's a vertical line. This is x equals to 2. Okay, what about this one? X equals to 2y. What's the graph of this one? Yeah? Okay, first of all, it's a line, right? What's the slope of this line?
1/2.
1/2, because you have to solve for y to get the slope, right? If you divide both sides by 2, you get y equals to 1/2 x. So you have the slope, which is 1/2, just like that, okay? And they meet at 2, 1. Okay? And certainly, if you have these two and then y varies from 0 to 1, it gives you this entire domain. Do you see it? Y varies from 0 to 1, that's the domain that you have. And you would get this integral if you're integrating e to the x squared over this domain, painting in which direction? Rightwards or upwards? this one is painting right or up? Right, yeah, it's going right because dx is inside, right? But now we want dy dx. In order to do that, we have to paint up. Okay, if you have to paint this region and you're being hired to do so, people are very careful about the boundaries. Do you know what people do in order not to go above the boundary? Huh?
They would trim around the whole thing.
They would tape, there's a painter's tape that you put on here, right? So you put blue painter's tape here and then and still you have to be very careful not to go beyond the boundary so that you have to be hyper aware of where you're beginning and where you're ending, okay? So where are you beginning? Where's your beginning point?
Zero.
Zero.
Y equals to 0, right? The equation for this y equals to 0. What's the ending boundary?
Y equals.
Y equals 1/2 x. That's what we just figured out, right? So that's where y equals to 0 is where you begin. This is where you end. So you have to say you start at y equals to 0 and you end at y equals to 1/2 x. It's still the same integrand, but we're trying to do dy inside and then dx. So when you put dy inside, then these values should be the values for y. Okay, y equals to 0, y equals to 1/2 x. That's what you should write. Okay, or people would just write 0 and 1/2 x. But always be aware that when you write these things, it's really y equals to 0 and y equals to 1/2 x. And these are, y equals to 0 is not a point, it's the equation that's describing a line. Okay? Right. And then dx goes from where to where? Well, if you integrate the y direction, then that has the effect of adding up all the values in the vertical direction and putting it all on the x-axis, okay? And then the x values go from what? 0 to 2. So now you put 0 to 2. Okay, so this integral is same as that one. Now let's see why this is better than the previous one. Well, see, as I said before, this is just a constant when you integrate by y, so this is simply e to the x squared times y, where you have 0 and 1/2 x. And then you have 0 to 2, dy, dx still intact. And now, 1/2 x goes into y, which gives you e to the x squared times 1/2 x. But when you plug in 0, 0 times anything is 0, so you don't subtract anything. And you're integrating 0 to 2 of this thing. Okay. Now, you might think, oh, we still have e to the x squared. What's different now? Well, something's very different because now, if you say u as x squared, then the derivative of x squared is 2x. And that x lives right here. Yeah. And because of this x saves the day. The u substitution suddenly works. Okay, so let me show you how that thing is done. You set u equals to x squared. Then du is equal to 2x dx, right? Yeah, so du means that you have to differentiate this by x and you attach the x, okay? And then you solve for dx so that dx is equal to 1 over 2x 1 over 2x du. This is what you get by dividing by 2x both sides. That's what you get. And then now you have pretty much everything to change this into. So this now becomes e to the u, okay, times 1/2 x, and dx now becomes 1 over 2x times du. Oh, and then there's another thing that you have to do. When x is 0, what's the value of u? When x is 0, u is
0.
0. When x is 2, u is
4.
4. So the values here should be 0 to 4. Because these should be the values of u, okay? And this x and this x, these x's can cancel out. 1/2 times 1/2 is 1/4. Let's leave that outside. Integral of e to the u du from 0 to 4. Now that interval is very easy. It's just either you plug in 4 and 0, and that gives you 1/4 e to the 4 minus 1/4 e to the 0. So it's 1/4 e to the 4th minus 1, because anything to the 0th power is 1, and I factored the 1/4 out, okay? So that's the final answer. So this shows you that not only being able to paint either vertically or horizontally and being able to choose the right one is important for ease of calculation. Sometimes one direction is impossible and the other one is possible.